Hey, we're back at it again. Mr. Crofton here from KO8. We're talking today about finding the area of regular polygons. It's a tricky concept, but we're going to see a couple examples to work it out. First thing here, I've got the steps really laid out of what we want to do. Now, this is in some detail, so hopefully you can refer back to this to help you out. First step. So if you're given this example here, which is this regular hexagon, a six-sided shape, first step is to break it into identical triangles all connected at this center point right here. Okay? We don't know what the area is of a hexagon overall, but if we break it into triangles, we can totally find that. Step two, find the central angle, then split it in half and create two right triangles. The central angle are the angles that are all right here. So we do 360 divided by, well, I cut it into 6 slices, gets me 60 degrees each. But it says then split that in half. I'm cutting that in half to get me 30 on each side. Now, this is the key part here. Step 3 says find the base and height of one triangle. You're going to need SOHCAHTOA here. This is a key concept that we just simply need to make sure that we know how to work these out. Step 4, after you got the height and base, you find the area of one of your triangles. Step 5, multiply it by the number of triangles you created. So that's kind of our step-by-step process to work through it. Or in short, a happier way to do it, find the area of one triangle, multiply it by the number of triangles you formed. Every single one of these triangles are exactly the same. If you get the area of this one, you find the area of all the others. It takes some steps to get that area, but that's all you need to do. So, let's try it out here. Find the area of a regular pentagon with an apothem that is 5 feet. First question you might be asking is, what the heck's an apothem? Apothem is the distance from the center point perpendicular to a side. That is 5 feet. Okay? And that is the height of our triangle. So going through our steps, the pentagon is a crazy shape with a lot going on. I want to focus on something easier. Focus on just that triangle. I'm even going to draw it separately over here. Boom. There's my triangle. I know that this is my height of 5. Okay. First step says find the central angle. That's this angle right here. So 360 divided by the number of sides, which is 5, gets me 72. But I'm cutting that angle in half, so I divide that in 2 and gets me 36. That's the angle I'm going to work off of. So this angle up here is 36 degrees. And the reason why I'm doing that is because I want to look at a right triangle. This one here. Okay. I got to find the base and height of my triangle. I already have the height of 5. I got to find the base, which is this here. Using my right triangle, this is my opposite side. I'm given my adjacent, so I want to set up tangent, because our SOHCAHTOA. Tangent of 36 degrees equals x over 5. All right? Put it over 1 and cross multiply, and I will get my x value there is going to be 3.633. I'm using 3 decimal places because this is not my final answer yet, and I want to be as exact as possible. Now, this is 3.633, but I want to find the whole base. The whole base, then, is going to be twice as long, so I multiply that by 2, and my whole base is 7.266. All right. I'm ready to find the area of one triangle. The area of one triangle is going to be 1/2 the base of my triangle, 7.266, times the height of my triangle, which I was given from the get-go of 5. That gives me an area of 18.164. That's my one triangle. That's this guy right here. I've done most of my work, but I gotta make sure I remember. That's one triangle, and there's 5 identical triangles. So my final answer is 18.164 times the number of triangles, which is 5, to get me a whopping total of 90.818. And that's going to be in feet squared because it's an area. Boom. There we go. All right. One down. We're doing pretty good here. Let's check out another. Find the area of a regular hexagon with a perimeter of 120 meters. Okay, so the perimeter is 120 meters. That means the distance around the whole thing. I know that each side, there's 6 of them, is going to be 20. Okay, so that means this is 20. All right. Now, looking at the shape, I'm like, oh boy, a lot going on. Calm down. Take a deep breath, Mr. Crofton. You can find the area of one triangle, then realize, hey, you've really got 6 of those identical triangles. So focus on this one, and let's draw it separately. Boom. All right. I drew the height in there because I got excited. You know, I'm so excited to find the area. But remember to go through your steps, right? First, find the central angle. So the angle's all happening at the middle. Add to 360, and there's a total of 6 of them. So each of those central angles is 60, but I've cut that in half to get 30. Let's go green again. So I cut that in half to get 30 on each side, but let's do it on our separate problem. 30 degrees there. All right, now I want to find the area of my triangle. So I need the base and I need the height. Good news is I've already got the base. 20 is that whole base. I need to find the height, so this is my x right here. Notice when I'm looking at this right triangle here, it's very easy to make a mistake and say that the base here is 20, but it's not, right? It's very clear if you identify your picture well, that's not 20, that's only 10, okay? So, I want to use a little trig again, and I can see pretty clearly it's my opposite and adjacent, so again, I'm going to use tangent. This time, tangent of 30 degrees equals my opposite side, which is 10, over my adjacent side, which is x. Put it over 1 and cross multiply, and I get my value for what I said is x, which is my height, to be 17.321. Fantastic. Wow. All right. I'm basically there now. I've got my base, and I've got my height. So let's find the area of a triangle. Area of this triangle is 1/2 my base is 20 times my height is 17.321. Okay, 1/2 base times height. Boom, boom, boom. Throw that in your calculator. You get the area of one triangle to be 173.210. You might notice if you're doing this in a calculator at home, we do have a little rounding error going on there, but as long as you're in the right ballpark, you're looking pretty good on this. All right. Okay, that's one triangle, but hey, there's more than one triangle involved here. So to find the area of the whole shape, it's going to be 170, let's change this. 173.210 times the number of triangles I formed, which was a whopping 6 triangles. And when I multiply that through, I get my total of 1039.230. This time my unit is meters squared. Awesome. There we go. All right, this seems somewhat manageable. Break it down. Notice the colors. Notice when I use them. You can totally do it. And the good news is, class ended 2 minutes ago, so we got time for one more example. Let's do one more really quick together, and then I think we're going to be feeling pretty good on this. All right, we're now asked to find the area of a regular octagon with a radius of 10. Okay, no unit given to me, so hey, I don't have to give a unit back. That's my rule of thumb. Radius now is where it gets tricky. What the heck's a radius? The radius is that diagonal drawn to a vertex. So that's what 10 is here, okay? It's going to be the same thing all around to every single vertex, because that's what a radius is, right? It's the same, think of it in a circle. It's that same idea. Excuse me. Okay. All right, interesting. Let's draw it separately. Notice my triangle doesn't have to be to scale. It doesn't matter. But I want to label that as 10, and why not label that as 10 too? Because they all are. And remember my steps. Find the central angles in the middle. always going to be a total of 360, but this time I'm cutting it into 8 equal pieces. Gets me 45 degrees, but I'm chopping that in half to get me 22.5. Oh no, decimal. That's okay. Decimals are fine. No problem. So this angle here is 22.5, making this angle right here not the best drawing, but either way, 22.5. Okay. Keep in mind, my goal is to find the area of one triangle. So I need to find the base of it, and I need to find the height of it. This is where you might be concerned. I don't have either. That's okay. I've got enough information now. Okay? So, let's see. Let's find the apothem first, what I've labeled here as x. This is my right triangle, keep in mind. All right? So my apothem is my adjacent side to the angle, and my radius is the hypotenuse. So adjacent radius, cosine of 22.5 equals x over 10. All right. Cross multiply, put it over 1, cross multiply, and solve. You get x is going to be equal to 9.239. Okay. This is one part I'm going to need. That's my height. I also need my base. So I'm going to have to do it again. And this time, my base I'll mark here as y is my opposite side. And why not keep using that 10? So opposite and hypotenuse is going to be sine. So now I got to do sine of 22.5 equals y over 10. Again, put it over 1 and cross multiply. You get y is 3.827. Now, keep in mind, that's y right here. My whole base spans the entire triangle. So really, 3.827 is half my triangle, half my base. I want to multiply it by 2, and I will get 7.654. Okay. So, find the area of my triangle. Here's my base. Here's my height. I got to use them both. Let's see, where can I stick here? I'll put it over here. So the area of one triangle equals 1/2 my base, 7.654, times my height, 9.239. Okay. Notice 2 roundings. Kind of multiply them together, then multiply it again. So I'm going to get some rounding error, but it's your job just to minimize it, all right? So you should get approximately 35.358 is the area of one triangle. Then again, once you find one triangle, you take that 35.358 and you realize, hey, I got more than one. I've got a total of 8 triangles, so I multiply that by 8, and I get a whopping total of 282.861, and I didn't get a unit, so I'm just going to put units squared. And that's my last area. Okay, so I think we've learned from these. These problems can be very involved, right? They can take some steps and they can take some time. But being good at those little skills, like SOHCAHTOA, things like that, are really going to help you out in the long run, okay? And keep in mind, have an eye out for special right triangles. I'm going to go back really quick and show you where there was one. Right here. This is a special right triangle, a 30-60 special right triangle. So if you used a height of 10√3, congratulations, you saved yourself a little work. So that saves you that tangent move there. Either way, look for shortcuts, find the best way possible. All right, if you're interested in getting a little practice, here are a couple examples. In one, you're given the apothem. In one, you're given the side length. So try one of them out. Pause it now, and then I'll show you the answers. Boom. There are your answers. See how you did? Hopefully it went well. Hopefully this helped. Good job. Keep up the good work, and see you out.